Again, ring is a triple, R plus dot, and R is a set, plus and dot is on just some binary operation. Rn plus forms abelian group, and Rn dot is monoid. Because abelian group is strong, if we wanna give more condition, more restriction maybe, we have to give some monoid, touch monoid condition. So it should have some extra, like having inverse, commute, or having neutral element. Such a case, we give some special name to this ring. When this monoid R dot is not only just monoid, but if it is also commute, it means let me A dot B equals B dot A. If it satisfies also this case, of course A, B are element of R, then we call R plus dot is commutative ring. Commutative ring. There is some other condition. 만약 if there is a 1, what is 1? 1 is 1 in R. What is 1? 1 is some neutral element or identity for multiplication. So A dot 1 is 1 dot A is just A. If such an element exists in set R, we call R is unitary ring. So R plus dot is unitary ring. Finally, if there is also, let us say R is unitary ring, but if we have extra condition, not on R, let us say R, this is set minus, so R minus 0. So if we don't include R 0 in it, let us define this is R star. So for example, A comma B minus A is just B. This is what we call set minus. So you remove element from this set. If we remove 0 from the set, we will write R star. And if this R star also have for all A in R star, because in number 0 doesn't have a multiplication inverse, you don't have a 0 inverse. We want to say only element except 0. It means except 0. There is an inverse. So there is an inverse such that A inverse or A inverse A is just R. Sorry. Identity was 1. So in this case, because it is unitary ring, because it is already there is some neutral element, but there is more we call division ring. What is this? R plus dot is division ring, or we sometimes call skew field. So this is all thing you need to know about ring. In fact, why we do this is that we want to see the structure of the numbers we know. For example, natural number and integer, and what is this is rational number or real number or complex number. These are all this is not ring, but others are ring. So they are all ring. And in fact, not just ring, integer plus and with some addition and multiplication we need to define, but I assume you already familiar with this, so I skip. Plus, so you know how to add numbers and you know how to multiply numbers. I assume this again. Then this is not ring, but others are all ring. And especially plus is number multiplication is commutative, so it is commutative. I just write commutative, and it is also every number that I choose here contains 1, so 1 is the multiplication identity, so it is also unitar. Not only unitar, it also have inverse? No, only these 3 have inverse. These 3 are not only unitar, it is division ring. If you notice, this unitar ring is needed to have a skew field or division ring, but commutative ring is totally separate axiom. So there are one more thing you have to know. Finally, it is called field. Field is similar. Field is just we write K. K comes from German word Körper. I'm not sure like this. I don't know it is correct pronunciation, but it is German word for body or field. So field is some K and plus and dot. And same K plus is abelian group. So plus is in general, plus is notation for abelian group. And also K dot is also skew field, commutative division ring. It is not group because you know, 0 again, 0 doesn't have any multiplication inverse. So if field satisfies these 2 conditions, a set satisfies these 2 conditions, and another is that, of course, plus and dot is distributive. This means that A dot B plus C equals A dot B plus A dot C. In the above, I write 2 conditions for distributive law, but in this case, we don't need to write 2 because it is already commutative. So one condition, already, if it is satisfied, A plus B dot C should be automatically A dot C plus B dot C. So this is already implied. So this is the condition for field. And this is very important. Maybe not important, but if you know this, your life is much good, rich, I say. So now you can distinguish field. In fact, these 3 are rational number and real number and complex number. These are not just ring, it is in fact field. So blah blah dot dot dot. Why I tell this? Because I want to tell what is field. Rational number, real number, and complex number. The most important numbers are rational number and real number and complex number. They are field. So I can say just if you wanna say something, number, it is usually field because you are treating real number or complex number in physics or astronomy. Sometimes you have to treat some integer. In that case, it is not a field. So next time, I'll explain what is vector space. But if sometimes there is some we call generalization of vector space called module. What is difference is the vector space you need a field, but module you need a ring. So it is a less restricted concept. But one good thing of why we use only vector space, why vector space is more familiar than module, because later we will say there is always spaces in vector space, but you cannot say about module. Anyway, this is something. If you don't remember, you just can see what is field. Field is just the set, and plus and dot is well defined, and k and plus, set and plus is abelian group, and k and dot is commutative division ring, and plus and dot, they are distributive. One more thing before I close, I'll tell. We are large, people are very large, so in group, people usually don't write this dot. So people just say, instead of g1 dot g2, people prefer to write g1 g2. In this case, you have to think that dot is hidden. So because I want to emphasize the operation, I write it, but usually people don't write it. And people just say, not telling operation explicitly, just to say group G. Then you have to think that people wanna say this one. Similarly, people don't say ring R, R plus dot. Many just say ring R. But if you say ring R, because why I tell this is that the operation is important. It assumes that there is some plus and dot satisfying Rn plus abelian, Rn dot monoid, and plus and dot are distributive. And finally, similarly, field. Also, people will say just field K. For the field, I will write this double line K. I don't know what is. In LaTeX it is mass BB. I don't know what is it, but this symbol will be used. So, but when you see field K, we are assuming there is a K and plus and dot. Also, I will always use this field K notation. I'll say field R. It is real number field. And field C, it is complex number field. So yeah, that's all.